Hi, it's math time with Mrs. Depperschmidt. This time we're going to work with some rectangles again and decide how to find the measurements of some angles when we don't know what they are. There's a way, as long as you understand the properties of rectangles. This is a figure that we'll be working with today. It's figure ROCK. And I've drawn a couple of angles inside the figure. We know it's a rectangle because of the tick marks, the parallel lines, and the 90-degree angles that are indicated. So as I turn the page, we're going to look at angle ROC first, and then angle CKR, and talk about how we can figure out what part of an angle is and the measurement for it without using a protractor. First off, to measure angle ROC, we know that because this is a rectangle, angle ROC is 90 degrees. It is a right angle. Then we're also told that that small part indicated with a curve is 60 degrees. With angles, the measurements add up. So we know that 60 and the question mark section, when added together, these are the two parts, make the whole of 90 degrees. We can do this as a subtraction problem. We say 90 degrees, subtracting 60 gives us 30. And it will work with angles all the time. As long as you can be certain that you're starting with a 90-degree angle, you do not need a protractor to find the measurement of the tiny slice that's shown with the question mark. We'll do one more. We're going to work with angle RKC next. And we have angle RKC is also sliced into pieces. We know we're using a rectangle, so we have a right angle in the corner. Angle RKC is 90 degrees. The small part that's shown is labeled 38 degrees. What's the measurement of the question mark angle? We know that the two parts must equal 90, so when we subtract, we get the result of 52 degrees for the small part of the angle. It's as simple as that, doing a subtraction problem to determine which amount the angle is. By the same token, you can figure out how long the sides of a square or a rectangle are by knowing parts or some other sides, just because of the definitions of squares and rectangle. Here's a rectangle with another little rectangle added on. And if we're wanting to find out how tall this rectangle is, we can use the measurements that are shown and the properties of squares and rectangles, because we can see that every angle is a right angle in this one. Even though the lines are drawn a little bit crooked, it's given that this figure is showing two rectangles. And we know that the rectangle is 8 feet tall altogether. One part is 3.5 feet, or 3 5/10. How do we find the length of the question mark part, the side that's not marked? Again, you probably know it's another simple subtraction problem. We use the 8, which is the total. We subtract the part we know, which is 3.5, and we come to the conclusion that the missing part is 4.5 feet. That's the size of the side that's not labeled, because we know that 4.5 added with the 3.5 would make 8 for our total. That's simple mathematics for finding the sizes of a rectangle and the lengths of the sides. We'll use this information to calculate perimeter of complicated figures in our next session. Here's a different rectangle. This is 503 millimeters. Actually, it's two rectangles. All of our angles are marked as right angles. We have the small one on top labeled. It's 148. What is the measure of this remaining part of the rectangle? the side that's not shown. Like I said before, simple subtraction, we have two parts that we need to use to make a whole. So we'll use the part whole explanation. We're going to say 148 with something we haven't figured out yet equals 503. We calculate using a subtraction problem. 503 minus 148 is 355 if you've done the regrouping correctly. That's how the measurements of rectangles and squares work with each other. You can translate these distances because you know that all of the angles are right angles and that we're only working with squares and rectangles. This will always work when you have figures that are squares and rectangles. I'm excited about your progress in math. You're doing really well. We'll get some more complicated squares and rectangles later on. I hope you're having a great day. Remember, please be kind.